Okay, in this video, we'll thoroughly review Unit 0 of AP Psychology in 1 hour and 14 minutes. So clear your desk, put away your phone, start your timer, and grab the structured study guide in the link in the description to fill it out as we go along. Unit 0 for AP Psychology covers the 4 scientific practices that you need to know for the exam. We'll start with the first, titled Concept Application. This practice is broken down into 2 lessons: psychological perspectives and norms and biases. Let's start with psychological perspectives. The key question being asked in this lesson is this: if you're given a scenario in the exam, can you use a psychological perspective to explain what's going on? Okay, so let's go through the psychological perspectives and apply them to scenarios. The 7 psychological perspectives you may come across in the exam are the biological perspective, the behavioral perspective, the cognitive perspective, the evolutionary perspective, the humanistic perspective, the psychodynamic perspective, and the sociocultural perspective. If you've already completed the core 5 units of this course, you'll recognize these by now. But if you're just starting your AP Psychology journey in Unit 0, no worries. I'll briefly summarize them now, and by the end of the 5 core units, you'll be able to explain each of these perspectives in your sleep. Okay, let's start with the biological perspective. This perspective examines how behaviors have a physical cause inside the body. For example, it looks at the brain, nervous system, hormones, and genes to see how these biological elements influence what people think, feel, and do. Let's apply this to a scenario. Imagine Jordan has been feeling unusually sad, tired, and unmotivated for weeks. A biological psychologist would suggest that Jordan's symptoms may be linked to low levels of serotonin in the brain. From this view, treatment would likely focus on medication or other methods that change brain chemistry. Now let's look at the behavioral perspective. The behavioral perspective looks at how people's behaviors are conditioned over time. It examines how we learn from past experiences and change our behaviors based on what we have learned. For example, a dog may learn to sit because it realizes it gets a treat every time it sits down. Let's apply this to a scenario. Imagine a student named Mia who studies every night after dinner. A behavioral psychologist would look at this scenario and note that Mia previously received praise and good grades when she studied consistently, and that's why she studies nightly. From this view, the studying habit developed because it was reinforced with positive rewards over time. Okay, next up is the cognitive perspective. This perspective explains behavior by focusing on mental processes such as memory, perception, and decision-making. For example, it examines strategies people use to commit information to memory, how people detect and process visual stimuli, and how people's decision-making processes are influenced by biases. Let's apply this to a scenario. Imagine a study where one student spreads her review sessions across several weeks leading up to the AP Psych exam, while another just crams the night before. The student who spread the review sessions out got a better score in the exam. You could look at this scenario and explain that the first student's strong performance happened because of a concept from the cognitive perspective called the spacing effect. This effect states that spacing study out over time improves how the information is encoded and stored in memory. Next is the evolutionary perspective. This perspective explains human behavior by considering how some traits may have helped humans survive and reproduce in the past. These traits have naturally survived while weaker traits have died out. An example is humans' strong preference for sweet and high-calorie foods, which may have helped early humans seek out energy-rich nutrition when food was scarce. So, let's apply that to a scenario. Imagine in the exam you're given a scenario where a person quickly jumps back when she sees a snake at the park. An evolutionary psychologist would suggest that humans evolved to rapidly detect and avoid potential threats. From this view, the person's reaction reflects an inherited survival mechanism. Okay, now let's look at the humanistic perspective. This perspective explains behavior by emphasizing personal choice, free will, and the drive to grow and improve. Famously, Abraham Maslow argued that human behavior is guided by the need for self-fulfillment. People seek out experiences that help them grow, find meaning, and reach their full potential. Now, let's apply this to a scenario. Imagine that Leo decides to audition for the school play even though he feels nervous. A humanistic psychologist would say Leo is motivated by a desire to grow and reach his potential, which helps him overcome his nervousness. From this view, the behavior reflects free choice and desire for personal development. Next up is the psychodynamic perspective. This perspective explains behavior by focusing on unconscious thoughts, early childhood experiences, and inner conflicts. It assumes that people are often influenced by feelings buried deep in their minds that they are not fully aware of. Hidden emotional conflicts, especially from childhood, can shape present-day actions and reactions. Here's how we can apply this in a scenario. Imagine Nina becomes extremely anxious whenever a teacher criticizes her work. A psychodynamic psychologist might suggest this reaction is connected to earlier experiences with harsh criticism in childhood. From this view, unconscious emotional conflicts are driving Nina's strong negative response to feedback. Lastly, let's look at the sociocultural perspective. This perspective says that behavior and thought process are shaped by culture, social groups, and social norms. Let's apply this in a scenario. Imagine Diego feels strong pressure to choose a career that his family approves of. A sociocultural psychologist would state that his family expectations and cultural values are influencing his thought process. From this view, Diego's decision-making is shaped by his social environment. Okay, so that brings us to the end of the free part of our first lesson on concept application. To recap, you need to be able to look at scenarios and consider how different psychological perspectives might explain what's going on. This lesson continues within Mr. Carter's AP Psychology Self-Study and Review System, linked in the description. To continue, navigate to this lesson using the navigation bar, click into the MCQ Practice tab, and we'll go through some MCQ practice questions for this lesson together. While you're there, you can download and complete this lesson study guide so you can take structured notes that will reinforce your ability to recall this information in the exam. Or if the exam's coming up in just a few days, just head to the 4-hour rapid review module and complete the complete course review video and rapid review playbook to get exam ready fast. Now, let's move on to the second lesson in this section titled Norms and Biases. The key question being asked in this lesson is this. If you're given a scenario in the exam, can you identify the cultural norms and cognitive biases that are present? For this lesson, we'll look at how cultural norms, expectations, and circumstances apply to a scenario, how cognitive biases apply to a scenario, and how psychological perspectives can be misused in discriminatory ways. So let's begin with cultural norms. Cultural norms are the shared rules in a society about how people are expected to behave. Cultural norms and expectations help explain why a person behaves in a certain way, even when the behavior seems unusual at first. You may be presented with a question in the exam about how cultural norms are influencing a study. Aspects to consider when thinking about cultural norms include the culture's values, such as if students are discouraged to speak up in class within their culture. Family expectations, such as if their parents are very strict and expect straight A's. And social roles, such as an expectation that older siblings should take care of younger children. Each of these often shape decisions and reactions. Let's consider a scenario. Imagine a student avoids speaking up in class because their culture strongly values respect for authority and quiet listening. In this case, you'd be expected to understand that the behavior is not necessarily about confidence or ability. It could be explained by cultural expectations and the social context. Now let's look at cognitive biases. The three mentioned in Unit 0 are confirmation bias, hindsight bias, and overconfidence. You may be asked to explore how any one of these apply to a scenario. So let's look at all three of them and apply them to scenarios. First is confirmation bias. Confirmation bias is the tendency to notice and remember information that supports what you already believe, while ignoring information that challenges your belief. For example, imagine a scenario where Sam believes that he is bad at math. After a test, he focuses only on the questions he got wrong and ignores the many he answered correctly. In this case, Sam is showing confirmation bias because he is paying attention only to information that supports his existing belief. Next is hindsight bias. Hindsight bias is the tendency to believe, after an event has happened, that you knew it all along. For example, after the winner is announced, James says he knew they would win the whole time. In reality, he had no special insider knowledge. This is hindsight bias because James is rewriting his memory to make the results seem predictable. Last is overconfidence. Overconfidence is the tendency to overestimate your own knowledge, skills, or accuracy. For example, Alex studies only briefly for a big test because he is sure he already knows the material well enough. He then performs poorly on the exam. This reflects overconfidence because Alex overestimated his level of preparation. The last outcome for this lesson asks you to explain the implications of applying psychological concepts or theories in inappropriate or discriminatory ways. In other words, can you identify situations where someone uses a psychological concept to stereotype, label, or unfairly judge a person or group? In the full course review, we touched on a few of these situations. For example, we looked at the concept of eugenics, where people have claimed that some groups are naturally superior to others. We also explored stereotyping, where group differences are oversimplified and used to make unfair assumptions about people, such as assuming someone must behave a certain way because of their gender, race, or background. In both cases, psychological concepts are taken out of context or misused to justify discrimination or unequal treatment. As a student of psychology, it is important to recognize when this happens and to think carefully about how psychological knowledge should be applied in ethical and responsible ways. Let's apply this skill to a scenario. Imagine a teacher assumes a student will perform poorly on a test because of the student's gender. This is an inappropriate application of psychological thinking because the teacher is stereotyping rather than evaluating the individual student's actual ability. The implication is harmful because it can lower expectations, create unfair treatment, and reinforce discrimination. All right, that brings us to the end of the free YouTube version of the second lesson. To recap, you need to be able to look at scenarios and consider how cultural norms might exist within a scenario. You also need to examine how biases might exist in a scenario and how that might affect the scenario. And finally, you need to be able to identify discriminatory use of psychological concepts within scenarios. This lesson continues within Mr. Carter's AP Psychology Self-Study and Review System. Click into the MCQ tab where we look at several scenarios and see if you can identify the norms, biases, and discriminatory practices at play. This is one of the harder MCQ practice quizzes I've made, so if you can get this right, you're doing well. Before you move on, don't forget to fill out the guided study notes pages for this unit as well. And then we'll dive right into the next lesson. Our next scientific practice for Unit 0 is titled Research Methods and Designs. This one is particularly important for the AAQ. In the article analysis section of the exam, you'll be presented with an article that summarizes a research study. For example, students who took Set 2 of the 2025 exam were given an article that summarized a research study that examined dogs' interactions with people they knew versus strangers. It was a real study, and students were required to answer questions about how the study was designed. So, after you read the article summary in your own exam, you'll be asked questions about the study's method and design. Questions like, identify the research method used in the study, and identify one ethical guideline applied by the researchers. I'll teach you everything you need to know about research methods and designs for the exam here. So, let's begin. For this scientific practice, there are 5 parts: types of research design elements, measurement instruments, ethical procedures, and peer review and replication. Let's start with types of research design. This lesson is important because you will be tested on it in the very first question you'll face in the article analysis question. For Part A of the AAQ, you need to read the article, then identify its research method. To win the point for this question, you'll need to state whether it uses an experimental or non-experimental research design. The AP Psychology course states that experimental research can be identified in 2 ways. First, an experimental study design contains independent variables, and second, it often involves the random assignment of research participants into groups. We'll begin with independent variables. Essentially, a variable is anything in a research study that can be measured or controlled. For example, in a study of how many hours AP Psych students sleep the night before the exam, one variable would be the hours of sleep. That's something the researcher is measuring. One way you can tell a study contains an experimental design is that it has 2 specific types of variables. One is the independent variable, which is what the researcher changes on purpose, and the other is the dependent variable, which is what the researcher measures as the outcome. For example, imagine a researcher is testing whether studying for more hours before a test increases students' grades. We have 2 variables here. hours spent studying, and students' grades. To test this, imagine the researcher splits students into two groups. The students in the first group study for 4 hours. The students in the second group study for 8 hours. Now let's see which variable is the independent variable and which is the dependent variable. Remember, the independent variable is the variable that the researcher changes and controls. The dependent variable is the outcome being measured. So if you said that the independent variable was hours studied, you'd be correct. The researcher is actively controlling this. Meanwhile, the student's test scores is the end outcome that the researcher wants to measure. So the key thing you need to remember is this. You'll be asked to read an article and determine if it contains an experimental design. Read the article and see if the researcher is manipulating a variable, known as the independent variable. If they are, then you've identified that the study uses an experimental design. Another way to identify experimental research is that it often randomly separates research participants into two groups. To use the earlier example, we had a study where a researcher manipulates how many hours students study for a test in order to determine the effect of study time on test scores. You'll notice that the researcher split the research participants into two random groups and asked one group to study for 4 hours, and the other group to study for 8 hours. This is so the researcher can compare the two groups to see how much those extra 4 hours of studying improve the test scores of the second group. In experimental research, these groups have names. The baseline group is called the control group. The group who gets the extra treatment is called the experimental group. We'll dig deeper into this concept in the next lesson. Okay, so to recap, an experimental design usually has an independent variable that's manipulated by the researchers, and it randomly splits research participants into groups, so each group receives a different dose of the independent variable. Look for these two features in the AAQ. If they exist, then the answer to part A is experimental design. Now let's look at non-experimental design. This can be broken down into 4 types of studies. They are case study, correlational analysis, meta-analysis, and naturalistic observation. A case study is an in-depth investigation of one person, a small group of people, or a single unique situation. The researcher does not manipulate any variables. Instead, they closely observe and gather detailed information without doing any manipulation. For example, a psychologist might spend months studying the behavior and recovery of just one patient with a rare brain injury. We can tell this is a case study because the researcher is only observing and documenting one case. And they are not changing variables, they are just observing. Next is correlational research. This type of research examines the relationship between two variables to see whether they're related. Importantly, correlational research is not experimental because the researcher does not manipulate or control either variable. In other words, there is no independent variable that the researcher touches. They're just watching. For example, a researcher might measure 500 students' study time and their grades to determine the relationship between study time and grades. However, they don't tell any student how many hours they're allowed to study and don't split them into groups because they're not conducting an experiment, they're just observing. Next is meta-analysis. This is a study that combines the results of many previous studies on the same topic and asks whether there are overall patterns across the collected research. For example, a psychologist might combine the results of 50 studies on the effectiveness of therapy for anxiety. The goal is to see if all or most researchers have come to the same conclusion, which shows that the results are very compelling. Last is naturalistic observation. This involves watching and recording behavior in a real-world setting without interfering. The researcher does not manipulate variables and tries to remain a fly on the wall. For example, a researcher might observe how children interact on a playground during recess without even talking to the students. They just watch. But, unlike a correlational analysis, they're not necessarily looking to measure two specific variables. They might just be trying to identify trends in behaviors or rich insights into the culture or group they're observing. Okay, so those are all the research designs that you could see in the exam. Remember, for Part A of the AAQ, you will need to identify whether the study is an experimental design or one of the 4 non-experimental designs. All right, that brings us to the end of the free YouTube version of this lesson. This lesson continues within the AP Psychology Self-Study and Review Playbook, where we look deeper at several study descriptions, and attempt to identify the type of research design being used. If you want to continue the lesson or grab the structured study guide, the link is in the description. And now let's move on to the next lesson, which zooms in on the different research design elements in a study. Again, your knowledge of this section will be directly tested within the article analysis part of the exam. So, let's dive in. We'll look at the following elements of research design: the hypothesis, research variables, participants and sampling, generalizability, and experimental groups. Let's start with hypotheses. A hypothesis is a prediction made by the researcher before they conduct their study about what they expect will happen. For example, a hypothesis might be, students who study for 8 hours will score higher on the test than students who study for 4 hours. The researchers will then carry out their study and determine whether their hypothesis was true or false. A hypothesis is only valid if it is falsifiable. This means that it can be tested and potentially proven wrong with evidence. If there is no possible way to show the hypothesis is wrong, then it is not scientifically useful. For example, a non-falsifiable hypothesis might be, students perform better when the universe is aligned in their favor. Here, there's no way we can scientifically test whether it is right or wrong, so it's no use to researchers. Okay, so let's see how you need to apply this in the exam. In Part F of the article analysis question, you will be expected to explain how at least one of the research findings supports or refutes the researcher's hypothesis. In other words, you're being asked to state whether the researcher's hypothesis was found to be true. Let's look at an example. Imagine you're presented with an article that hypothesizes that students who use flashcards will score higher on a vocabulary test than students who do not. After the study is completed, the results show that the flashcard group scored significantly higher than the non-flashcard group. In the exam, you'd be able to say that this finding supports the researcher's hypothesis because the predicted outcome that the flashcard group would score higher actually occurred. The flashcard group scored 82 on average, while the non-flashcard group scored 65 on average. Okay, so that's what you need to know about hypotheses. Now let's look at what you need to know about variables. Here we'll discuss 4 variable-related concepts you need to know about. You'll already recognize 2 of them. Our 4 concepts are operational definitions of variables, independent variables, dependent variables, and confounding variables. Let's start with the operational definition of a variable. An operational definition is a clear statement of how the variable will be measured or manipulated in a study. Let's look at an example of an operational definition. Imagine a researcher is studying stress in AP psychology students. They will need to tell people how they defined and measured stress. So they might say that the operational definition of stress for this study was a participant's score out of 20 on a standardized stress questionnaire, where participants answer a series of questions about how often they feel overwhelmed, worried, or tense, and their responses are combined into a total stress score. Operational definitions are important because they allow the study to be replicated. In other words, future researchers will be able to use the same definition and run the same study again to see if they get the same results. For example, for the stress study, future researchers would be able to use the same stress questionnaire to define and measure stress in a comparable way in their study. Okay, so here's why you really do need to know about operational variables for your AP Psych exam. In Part B of the AAQ, you will be asked to identify the operational definition of a variable. They will tell you the variable. For example, in this question, you're asked for the operational definition of self-regulation, which is the dependent variable being examined in the study. So you'll essentially need to read through an article and find out how they've defined it, and then provide an answer such as, the operational definition of self-regulation used in the study was each adolescent's ability to control their emotions and actions, which was measured using a computerized task and a short questionnaire. By the way, this practice AAQ and answer set is from the AAQ Mastery Playbook. You can go through all my practice AAQs and have a go at finding the operational definitions. The playbook is linked in the description. Okay, let's move on to the independent, dependent, and confounding variables. The independent variable is what the researcher changes or controls. The dependent variable is what the researcher measures as the outcome. And the confounding variable is an outside factor that could influence the dependent variable and make the results unclear. Okay, so let's look at an example study that contains all three of these types of variables. Suppose a researcher tests whether listening to classical music reduces people's stress levels. The researcher tests people's initial stress levels. Then, they split people into two groups and tell them to sit in the waiting room for a while. One group sits in silence for 15 minutes. The other has classical music playing while they wait. After the 15 minutes is up, stress levels are retested to see which group is more relaxed. So, the independent variable is what the researcher manipulates. Here, the independent variable is classical music, because that's what the researcher is manipulating and controlling. One group gets it, the other group doesn't. The dependent variable is what the researcher is measuring as the final outcome. In this study, the researcher is measuring stress levels. But imagine there's a confounding variable. We just define this as an outside factor that could influence the dependent variable. Imagine some participants drank coffee before the experiment, and the researchers weren't aware. Caffeine would be a confounding variable because it could affect their stress levels and mess up the results of the study. Okay, that's it for variables. Now let's look at participants and sampling. First, we'll define participants, sample, and population. And then we'll explore the sampling methods you need to know about for AP Psychology. And then we'll look at a concept called sampling bias. Let's start with our three definitions. First is research participants. These are the people or animals who take part in the study. Sometimes the participants are also called the sample. The sample are supposed to be representative of a larger group. The larger group is known as the population, which is the broader group the researchers ultimately want to understand. For example, a researcher might look at how 40 Labrador dogs behave around squirrels. Those 40 dogs, who are the participants in the study, are known as the sample. But this sample is supposed to be representative of Labrador dogs more broadly, which the researchers want to know about. So the population that the study is trying to understand is Labrador dogs, of which there may be millions. Okay, now let's look at sampling methods. These are the ways in which the researchers went about finding people or animals to participate in the study. For AP Psychology, you need to know about two methods for finding research participants. These are random sampling and convenience sampling. Random sampling occurs when the researchers randomly select members of the population to participate in the study. For example, researchers might want to conduct a study about young adults. That's the target population. So they call random phone numbers, ask people their age, and then invite people to participate in the study if they're aged 18 to 25. Here, because the phone numbers are random, they've randomly selected research participants from the young adult population across America. The benefit of this method is that it usually produces a sample that is highly representative of the broader target population, which helps with generalizability. We'll get to generalizability in a moment. The other method of sampling that you need to know about for the exam is called convenience sampling. This occurs when researchers choose participants because they're easy to access, such as when a professor just chooses students in his classroom and asks them to be in his study. This method is faster but often less representative of the broader population because the people weren't truly selected at random. Before we conclude our discussion of participant sampling, you need to know about a concept called sampling bias. This is when the participant sample does not reflect the population. When this happens, certain groups might be overrepresented or underrepresented in the study. For example, imagine researchers want to study how many hours per week teenagers sleep. Teenagers is the broader population that the researchers are trying to get information about. But out of the 50 teenagers in the study, it turns out that 45 of them were male and only 5 were female. This isn't truly representative of the makeup of the broader population of teenagers, which should be roughly 50% male and 50% female. So the sample is biased and not representative of the broader population. Perhaps female teenagers have different sleep patterns to male teenagers. So the study can't truly generalize to a population of all teenagers. Its results are more relevant only to a broader population of male teenagers. Overall, when the sample closely reflects the target population, the findings are more meaningful and useful. That brings us to another really important term for the AAQs, generalizability. This refers to how well the results of a study can be applied to the larger population. In other words, it asks, can we reasonably extend these findings beyond the sample? Generalizability is strongest when the sample is large, diverse, and randomly selected from the population. This makes the sample highly representative of the broader population that the researchers are trying to understand. But generalizability is weaker when the sample is small, unrepresentative of the broader population, or chosen through convenience sampling. For example, if a study about study habits of high schoolers only includes students from grade 11, the results may not generalize well to high school students of different grades. However, if the sample includes randomly selected students from many different grades and backgrounds, with a strong gender and ethnic mix that reflects the broader American population, then the results are much more likely to generalize. For Part E of the AAQ, you will have to assess whether the findings in the study are generalizable. If you've gone through my AAQ playbook and video walkthrough, linked in the description, you'll know that I give my students a template for how to answer this generalizability question in the AAQ. It reads, the study is or is not generalizable to a larger population, for example, students, because that population was or was not well represented in the study, which contained, and then explain how many of that population were represented in the study. A filled-in version might read, the study is not generalizable to a larger population of high school students, because that population was not well represented in the study, which contained students from just one grade, grade 11, rather than all high school grades. For practice on how to test generalizability in AAQs, don't forget to check out the AAQ masterclass that's part of Mr. Carter's AP Psychology Self-Study and Review Playbook. It's linked in the description. Okay, the last thing we need to know in our Elements of Study Design lesson is experimental and control groups. Essentially, as you'll remember from the previous lesson, an experimental design often splits people into two or more groups. Those groups have names. The first group, known as the control group, are often left untouched. The researcher doesn't manipulate any variables and just observes them to see how an untouched group would behave. The second group, known as the experimental group, has an independent variable manipulated. For example, the researcher might give them a sleeping pill, or tell them to study for an extra 4 hours before the exam. Essentially, the researcher wants to test the effect of the intervention on the experimental group and compare it to the control group. All right, that brings us to the end of the free YouTube version of this lesson. This lesson continues within Mr. Carter's AP Psychology Self-Study and Review Playbook, where we look deeper at several study descriptions and attempt to identify the elements of the research design. If you want to continue the lesson, practice exam-style AAQs where you'll need to apply this information, or grab the structured study guide that goes along with this video. The link is in the description. Okay, our next lesson is about measurement instruments. We'll look at common ways data are measured in quantitative research, and then qualitative research. Then we'll explore how results might be invalidated by a range of factors called confounds and biases. Okay, so let's start with quantitative research. This is research that focuses on numbers and measurable data. Two common measurement instruments in quantitative research are Likert scales and multiple choice questions. Likert scales are rating scales that ask participants to show how much they agree or disagree with a statement. For example, a survey might ask students, is the AP Psychology exam too difficult? On the Likert scale, students would rate their agreement from strongly disagree to strongly agree. Likert scales turn opinions and attitudes into numbers that researchers can analyze. For example, researchers might assign each response a score from 1 to 5. They can then analyze the results numerically, such as by calculating the average response across everyone they surveyed. Another quantitative measurement instrument is a multiple-choice questionnaire. These are questions that provide several answer options, with participants selecting the one that best fits. Multiple-choice questions can produce clear numerical data that can be quickly analyzed. For example, researchers might be able to identify that 35% of participants answered question B and 13% answered question C. Next, let's look at qualitative research. This is research that focuses on detailed descriptions of people's experiences, thoughts, and feelings. Instead of numbers, qualitative research collects rich, in-depth information, often in the form of detailed descriptions, that helps researchers understand the meaning behind the numbers. Two common measurement instruments in qualitative research are interviews and group discussions. Interviews are conversations in which a researcher asks participants questions to discuss their experiences or views in depth. This allows participants to explain their thoughts in their own words rather than just ticking a box. This gives researchers detailed insights. Group discussions are guided conversations with several participants at the same time, often called focus groups. In these discussions, participants respond to questions and also react to each other's ideas. This helps researchers see shared themes, different perspectives, and how opinions are formed in social group settings. Okay, now you know the common measurement instruments that you need to know about for AP psychology. Let's talk about some ways those measurement instruments might fail. Essentially, biases and confounding variables can skew the results of studies. Obviously, researchers want to avoid this, so let's discuss. For AP psychology, you need to know about the following biases and confounds: experimenter bias, self-report bias, social desirability bias, placebo effects, survey wording, the directionality problem, and the third variable problem. We'll also look at how single-blind and double-blind procedures can be used to address placebo effects. Okay, so let's start with experimenter bias. This is when the researcher's expectations accidentally influence the results of the study. For example, a researcher might unconsciously give more attention and encouragement to the experimental group and not the control group. Because of this, the results may reflect the researcher's influence rather than the intervention itself. The next one you need to know about for AP psychology is self-report bias. This is when participants do not give fully accurate answers about themselves. This can happen because people misunderstand the question or even intentionally give inaccurate answers. When this happens, the data collected may not reflect reality. Social desirability bias is similar to self-report bias. It occurs when participants answer questions in ways that they think will make them look good to others. Instead of being completely honest, they may choose answers that seem more responsible or socially acceptable. Social desirability bias is common in focus groups because other people hear their answers in a social setting. Next is the placebo effect. This refers to improvements in symptoms that occur simply because they expect the treatment to work. This may happen in two circumstances. First, a research participant may be given a sugar pill rather than the real treatment. They report feeling better despite not actually receiving anything. Second, a research participant may be given the real treatment, but the positive effect is entirely psychological rather than materially due to the treatment itself. For AP psychology, you need to know how researchers reduce the influence of the placebo effect. They do this through processes called single-blind procedures and double-blind procedures. In a single-blind study, the participants do not know whether they are receiving the real treatment or a placebo. For example, imagine a study testing a new pill to improve sleep. One group receives the real pill, and another group receives a placebo pill that looks identical but has no active ingredient. Because the participants do not know which pill they received, their expectations are less likely to influence the results. Double-blind procedures go one step further. In a double-blind study, the participants do not know who received the treatment, but the researchers who interact with them don't know either. Instead, the information is kept hidden by another researcher who is not directly involved in the study. This helps to reduce the placebo effect and experimenter bias. Overall, by introducing uncertainty about whether someone received the real treatment or a placebo, researchers can reduce the influence of the placebo effect on the study's results. Next is survey wording. A study can be affected by the way a question is written. If a question is confusing or emotionally loaded, participants may be pushed toward giving a certain answer. Consider this example. Here's a leading question. How helpful was the excellent new school tutoring program? This leads the participant to say that the tutoring program was actually excellent. By contrast, an example of neutral wording might be, how helpful was the new school tutoring program? This would not lead the research participant to give an overly positive or negative response. Overall, good researchers write neutral, clear questions to reduce this problem. Okay, next is the directionality problem. This occurs in correlational research when it is unclear which variable is causing the other. Let's look at an example. Let's say researchers find that people who exercise more report lower stress levels. But because they conducted a non-experimental correlational study, they may not have proven which one is causing the other. They don't know if exercise reduces stress or just that less stressed people are simply more likely to exercise. This problem is very common in correlational analyses. You should recall from the previous lesson that correlational analyses don't involve variable manipulation or separating people into control and experimental groups. Researchers may need to conduct a true experiment with control and experimental groups to answer the directionality problem. Finally, we have the third variable problem. This is when a hidden outside factor is actually causing the relationship between two variables. For example, ice cream sales and shark attacks both rise in the summer. An untrained researcher might think that ice cream sales cause shark attacks or vice versa. But in reality, there is a third variable in effect: hot weather. This sends more people to beaches and boosts ice cream purchases. Okay, that brings us to the end of the free YouTube version of this lesson. Hopefully you will have completed the structured study guide section for this lesson by now. This lesson continues within the AP Psychology Self-Study and Review Playbook, where we look deeper at several studies and attempt to identify their measurement instruments and possible biases and confounds. Okay, now let's move on to the next lesson, which covers everything you need to know about ethical procedures in psychological research. The key outcome you need to master for this section is: can you evaluate whether a psychological research scenario followed appropriate ethical procedures? For this lesson, we need to cover the importance of institutional review, informed consent and assent, protection from harm, confidentiality and anonymity, deception and confederates, and debriefing techniques. Let's start with institutional review. This is the process where a research study is evaluated by an independent committee before the study can begin. The committee asks questions such as: is this research ethical? Has it protected the rights of human and animal participants? And will it cause any harm? Studies need to be approved by this committee before they can proceed. The next 5 ethical procedures are all assessed by the Institutional Review Committee before the study can commence. So, let's look at the next one. It's called informed consent and assent. Informed consent is when participants are given clear information about a study and voluntarily agree to take part. This is important because participants have the right to understand what they're agreeing to and the right to decide for themselves whether they want to participate. However, when the participants are minors, they usually cannot legally provide informed consent. Instead, researchers seek informed assent, which is when a minor agrees to participate in a study after the study has been explained to them in an age-appropriate way. Often, a parent needs to give consent and the minor needs to give assent, and then the study can proceed. The next concept is protection from harm. Protection from harm means that during the study, researchers must take steps to make sure participants are not exposed to unnecessary physical harm or unnecessary psychological harm. For example, if a study asks participants to stand at a height to measure fear responses, the researcher must make sure there are safety barriers in place so the participants cannot fall. The next concepts are confidentiality and anonymity. Confidentiality means that the researcher must keep the participants' identities private. For example, when the results are published, the researcher may not use a person's real name, but instead use a pseudonym. This is important because participants may be more willing to give honest answers if they know their personal information will be protected. Anonymity goes a step further. This means that the researcher does not collect any identifying information at all, so the participants' identities cannot be linked to their responses, even by the researcher. Okay, now let's move on to deception and confederates. We'll start with confederates for this one. Confederates are people who secretly work with the researchers and pretend to be regular participants in the study. For example, in a study of the bystander effect, a confederate might pretend to drop a stack of papers to see whether the real participants in the study stop to help out. Now let's look at deception. This is when researchers intentionally withhold information or mislead participants about the true purpose of a study. This is sometimes used because if participants knew the real goal of the research, their behavior might change and affect the results. However, an institutional review board must approve of the deception beforehand to ensure it is not going to cause harm to the research participants. Usually, deception also requires debriefing after the study is complete. This is when researchers explain the true purpose of the study to participants after the study is finished. They reveal their deception and may also reveal who the Confederates were. This gives participants the opportunity to withdraw their data from the study if they are uncomfortable with what happened. All right, now let's look at how you might have to apply this information in the exam. Again, it applies directly to the article analysis section. In Part D of the AAQ, you'll be asked to identify one ethical guideline applied by the researchers. You will have to read through the provided article and find an instance where the study mentions institutional review, informed consent or assent, protection from harm, confidentiality and anonymity, deception and Confederates, or debriefing. Then, your free response answer will be something like, one ethical guideline used in the study was the use of debriefing to inform the research participants of deception and give them a chance to withdraw their data from the study. All right, that brings us to the end of the free YouTube version of this lesson. This lesson continues within Mr. Carter's AP Psychology Self-Study and Review Playbook. To continue, head over to the MCQ Practice tab, and we'll go through some MCQ practice questions for this lesson together. While you're there, you can download and complete this lesson's study guide, or if the exam's coming up in just a few days, just head to the 4-hour Rapid Review module and complete the complete course review video and Rapid Review playbook to get exam ready fast. The final lesson in this scientific practice is about peer review and replication. Essentially, the key idea here is that conclusions from a study need to be tested by the scientific community to ensure they are accurate and of high quality. This is done in two ways: peer review and replication. Peer review is the process where other qualified scientists carefully evaluate a study before it's published. This shouldn't be mistaken for institutional review. Institutional review happens before the study to ensure it's going to be ethical. Peer review happens after the study is completed. It ensures the study was conducted to a high quality. The reviewers check whether the research methods were carried out appropriately, the data were analyzed correctly, and whether the conclusions are supported by the evidence. For example, once a psychologist completes a study about memory improvement, other psychologists will review it and may suggest fixes or reject it if the research is weak. If the fixes are made, the study results get published. Overall, peer review helps catch errors and improves the quality of published research. The other way of testing results is replication. This is the process of repeating a study to see if the same results happen again. A finding becomes more trustworthy when different researchers can reproduce it in new studies with new participants. For example, if one study finds that listening to music improves concentration, other researchers might run the same experiment with a fresh set of research participants. If they get similar results, confidence in the original finding increases. All right, that brings us to the end of the free YouTube version of this lesson. This lesson continues within Mr. Carter's AP Psychology Self-Study and Review system, where we look deeper at how to apply this information in the exam. If you want to continue the lesson or grab the study guide to take guided notes as you watch the video, it's all linked in the description. Let's move on to the third scientific practice, titled Data Interpretation. This section is all about looking at the data in scientific studies and interpreting its meaning. It's important for all parts of the exam, including the MCQs, the AAQ, and the EBQ. In this section, we need to cover how to identify concepts in descriptions and data, how to calculate data, and how to interpret data. Let's start with identifying concepts. For the exam, you'll need to be able to identify variables in data and psychological concepts in data. For identifying variables, you need to be able to spot the key variables in a study when you are given a written description, table, or graph. You should recall from the last lesson that we have two main variables: the independent variable, which is the variable being manipulated by the researcher, and the dependent variable, which is the variable that the researcher wants to measure. So let's quickly look at how you can identify them in a written description, a table, and a graph. Let's start by looking at written descriptions. Imagine you get a written description of a study's results, which reads, "Students who studied for more hours tended to earn higher test scores." For AP Psychology, you'll need to be able to identify the independent and dependent variables from this description. So let's do this together. We'll start with the independent variable, which you'll remember is the variable that the researcher manipulates or controls. If you identified that the independent variable is the number of study hours, you're correct. The researcher is comparing students who studied for more hours versus those who studied for less. The dependent variable, which you'll remember is the final outcome being measured, is the test scores, because it's the key thing the researcher wants to measure. Okay, now let's look at how to identify variables in a table. Imagine a researcher studies how much sleep students get and their average reaction time on a driving simulation. It's presented in the table shown on screen now. So again, let's find the independent variable and dependent variable. So the independent variable will be the thing that the researchers manipulated to ensure it is different across the three groups. Here it's sleep time. The dependent variable is what the researchers measured to find out the effect of the intervention. For this study, it's reaction time in milliseconds. Third, let's look at graphical data. Picture a vertical bar graph with type of study method on the horizontal axis and average quiz score on the vertical axis. In most vertical bar charts, the horizontal axis shows the independent variable, and the vertical axis shows the dependent variable. In this chart, the researcher has given 3 different study methods, so that's the independent variable that the researcher controlled. And then they measured average quiz score across the 3 groups, so that's the dependent variable that is being measured. So, for the exam, remember, first, to identify independent variables in descriptions, tables, and charts, ask what is being changed or compared. Second, to identify dependent variables, ask what is being measured. Answering those 2 questions will usually lead you directly to the correct variables. Okay, the next part of identifying data is the skill of identifying psychological concepts depicted in tables, charts, and graphs, or figures. This is a skill you'll need in the EBQ section, where you're explicitly asked to look at studies and identify psychological concepts that they demonstrate. So let's go through some examples. We'll start with tables. Here's an example of a table that contains a psychological concept. It compares infants classified as securely attached and insecurely attached on 2 categories: time spent exploring and distress when caregiver leaves. It shows that securely attached infants spent 12 minutes exploring, while insecurely attached infants spent 6 minutes exploring. It also shows that securely attached infants scored a 2 out of 5 in a distress scale when their caregiver left the room, while insecurely attached infants scored 4 out of 5. So overall, it shows that infants classified as securely attached spent more time exploring and were less distressed when their caregiver left than infants classified as insecurely attached. You'd need to be able to explain the psychological concept that's being tested. So if you identified that the study is testing attachment styles, you would be correct. By the way, if you can't remember the concept of attachment styles, it's in Unit 3, Lesson 6. Okay, next is charts and graphs. Examples include bar charts, line graphs, pie charts, histograms, and scatter plots. Here's an example of a chart that contains a psychological concept. This chart represents a study where researchers compared 2 focus groups. The control group, presented on the right-hand side of the chart, were asked a series of yes or no questions without intervention. It shows that about 90% of the participants gave the correct answer, and about 10% gave the incorrect answer. The experimental group, presented on the left, witnessed Confederates giving the incorrect answers before being asked the questions themselves. The experimental group gave the incorrect answer about 75% of the time, and they only gave the correct answer about 25% of the time. If you were presented with this chart in the exam, you'd need to be able to explain the psychological concept that's being demonstrated. So if you identified that the chart is demonstrating the conformity effect at play with the experimental group, you would be correct. For more on the conformity effect concept, you can find it in Unit 4, Lesson 3. Next is figures. Figures often include diagrams and images. For example, a brain scan figure highlights that when a visual stimulus is presented to the left visual field, activity appears in the right hemisphere of the brain. You'd need to be able to explain the psychological concept that's being demonstrated. If you identified that the figure reflects findings from split brain research about hemispheric specialization, you would be correct. For more on split brain research, go to Unit 1, Lesson 4. Okay, that brings us to the end of the free YouTube version of this lesson. To summarize, you need to be able to identify variables and psychological concepts within descriptions, tables, charts, and graphs, and figures. Hopefully you will have completed the structured study guide section for this lesson by now. If you haven't got it yet, it's linked in the description. This lesson continues within Mr. Carter's AP Psychology Self-Study and Review System, where we look deeper at several studies and attempt to identify the psychological concepts within the data. This extra section will really help with the EBQ, so if you want to continue the lesson, you know where to get it. Our next lesson is on calculating data. For the exam, you're expected to be able to understand how data is calculated. This includes the 3 measures of central tendency, 2 measures of variation, the elements of the normal curve, percentile rank, and regression toward the mean. So let's begin. Measures of central tendency tell us what the middle of a data set looks like. 3 types are mean, median, and mode. Mean is the average score. You find it by adding all the numbers and dividing by how many there are. For example, if 5 students score 6, 8, 10, 10, and 6 on a quiz, then the mean is arrived at by adding those numbers together to get 40, then dividing them by 5, because there are 5 total numbers, and the mean comes out to 8. Now let's look at median. This is the middle number when you line up the scores from lowest to highest. For example, if your numbers are 2, 4, 7, 9, and 10, the median is 7 because it sits in the center of the list. There are 2 numbers to the left of it and 2 numbers to the right. Now let's look at mode. This is the score that appears most often. For example, in the set 3, 5, 5, 8, and 9, the mode is 5 because it shows up twice while all the other numbers just show up once. Okay, so that's it for measures of central tendency. The most common of these that comes up in the AAQ is the mean, which is simply the average of all the numbers. But there's a good chance all 3 of them will appear within the MCQ part of the exam. Now we'll move on to measures of variation, which tells us how spread out the data are. For this, the AP Psychology course description requires you know about 2 concepts: range and standard deviation. Range is the distance between the highest score and the lowest score. For example, if the shortest person in a group is 4 feet 2 inches tall and the tallest is 4 feet 9 inches tall, the range is 7 inches. Standard deviation shows how much the scores spread out from the mean. For example, in this chart, each blue dot represents a student's test score. Let's say that the mean score is 50. If almost every student scores close to 50 on the test, the standard deviation is low. But if scores jump way above and below 50, the standard deviation is high. Before you panic about this, remember, it's not a math test. You need to understand this concept, but in the exam, you likely won't need to do complex math. To get some practice on exam-style questions involving standard deviation, you can always complete my MCQ practice questions and watch the MCQ walkthrough for this lesson. They're linked in the description. Overall, here's the key takeaway. A low standard deviation means the results are clustered together, and a high standard deviation means the results are spread out. Now we'll move on to the bell curve, which you can see on the screen now. For this, we'll look at the normal curve, percentages across the curve, skewness, and bimodal distribution. The normal curve is a smooth and symmetrical bell-shaped graph where most scores fall near the mean and fewer scores appear at the extremes. This curve is very common in statistics because many things naturally fit upon this curve. Let's use human heights as an example. On the y-axis, we have the number of people. On the x-axis, we have heights. So we can see from the curve that 300,000 people are 5'6". Human heights follow a normal curve because a great number of people are close to average height, with fewer extremely tall or short people. Now let's move on to percentages across the curve, which tell us how much of the data falls within each standard deviation. As a reminder, standard deviation is a measure of how spread out numbers are in a data set. A low standard deviation means most scores are close to the mean. Earlier, I depicted this as blue dots clustered near the middle of the x-axis. On a bell curve, it looks like this. Because many scores are close to the mean, the curve has a higher and sharper peak. By contrast, a high standard deviation means the scores are spread farther from the mean. Earlier, I depicted this as blue dots spread out across the axis, representing a wider dispersal of scores. On a bell curve, this produces a flatter, wider shape because the scores are less concentrated around the mean. In a symmetrical curve, there's a rule called the empirical rule, which states that about 68% of all scores fall within one standard deviation of the mean, and 95% fall within 2 standard deviations. These percentages across the curve stay consistent on a normal symmetrical curve, regardless of if the standard deviation is low or high. So let's look at how this might appear in the exam. Imagine you're presented with this question. It reads, a researcher tests two different study environments. Both groups earn an average score of 78 on a psychology exam. The exam scores for each group form a normal distribution. Then, you're presented with a table that shows that one standard deviation for the music group was 12 points. In other words, about 68% of students earned within 12 points of the mean, which was 78 points. Meanwhile, the silence group had a standard deviation of 4. This means that about 68% of students earned within 4 points of the mean, so their scores were somewhere between 74 and 82. If we were to draw bell curves for these two scenarios, they would look like this. The music group would have a higher standard deviation, and the silence group would have a lower standard deviation. The question asks, which conclusion about the two study environments is best supported by the data? The answer options are, students studying with music performed better overall. Students studying in silence showed more similar performance levels. Music caused higher test scores, silence caused higher motivation. The answer requires that you know that lower standard deviation means that scores are more clustered around the mean, and a high standard deviation means that scores are more spread out. As a result, we know that the answer is B. The students studying in silence had a lower standard deviation, meaning their scores clustered around the mean, so most of them had very similar performance levels. Okay, so far we've discussed how the normal symmetrical curve behaves. But for AP Psychology, you also need to know about two other ways curves can behave. First is skewness. This happens when a distribution is pulled more to one side, so the graph becomes uneven. This creates positive skew and negative skew. Let's look at positive skew. Imagine a math test is very hard and most students score low. In this case, most scores will cluster near the lower end of the graph. The distribution will then have a long tail stretching to the right. Similarly, if the test is very easy and most students score high, most scores will cluster near the upper end of the graph. The distribution will then have a long tail stretching to the left, which is called negative skew. For AP Psychology, you may need to discuss skewness in a graph, but tests do not generally ask you to interpret standard deviation for skewed graphs, because standard deviation assumes that scores spread fairly evenly around the mean, which is not true in a skewed distribution. The other abnormal curve that you need to know about for AP Psychology is a curve with bimodal distribution. This occurs when a curve has two peaks instead of one, meaning two scores are especially common. For example, if you looked at students' bedtimes, you might see one peak around 9 p.m. and another around 11 p.m., creating two bumps in the graph. Now let's move on to percentile rank. Percentile rank tells you the percentage of scores that fall at or below a person's score. For example, if you are in the 80th percentile on a reading test, it means you scored as well as or better than 80% of students, and 20% of students scored better than you. Lastly, we have regression toward the mean. This means that extremely high or low scores usually move closer to the average the next time you measure them. For example, if you flip a coin 10 times and somehow get 9 heads, your results might appear very skewed. But if you kept flipping the coin 100 times, you're far less likely to get 90 heads. Simply put, smaller numbers can tell a deceptive story. But with the more times we test something, the more likely it is that we smooth out those rare and exceptional events. Okay, that's the end of the free YouTube version of this lesson. To continue with the lesson, jump into Mr. Carter's AP Psychology Self-Study and Review System, linked in the description, where we continue with some walkthroughs of how this information might appear in exam questions. And before you move on to the next lesson, make sure you've completed the structured study guide for this section. Okay, our last lesson for scientific practice number 3 is titled Interpreting Data. In this section, you need to be able to interpret results from research that could be expressed as trends in a scatter plot, Cohen's d, and statistical significance. Let's start with trends on scatter plots. This skill is about reading a scatter plot and explaining what the pattern shows. In a scatter plot, the horizontal axis shows one variable, and the vertical axis shows another variable. Each dot represents one participant's scores on both variables. The line on a scatter plot is called the line of best fit, which shows the overall trend or relationship between the two variables. For example, a researcher might place hours of exercise on the horizontal axis and stress levels on the vertical axis, with each dot representing one participant's exercise amount and their reported stress level. The line of best fit shows that as exercise increases, stress tends to decrease. Okay, so let's look at the key concepts you need to understand for the exam. In the exam, you may be asked to describe the direction of the correlation and the correlation coefficient, which explains both the strength and direction of the correlation. Let's start with direction. Essentially, the slope of the line of best fit shows the direction of the relationship between the variables. Okay, so we're going to look at three directions: positive correlation, negative correlation, and no correlation. Let's look at positive correlation. When the line slopes upward from left to right, this shows a positive correlation, meaning that as one variable increases, the other tends to also increase. For example, when students spend more hours studying, they tend to earn higher exam scores. Okay, next is negative correlation. When the line slopes downward from left to right, this shows a negative correlation, meaning that as one variable increases, the other tends to decrease. For example, when people exercise more frequently, they tend to report lower stress levels. Now let's see what no correlation looks like. On this scatter plot, the dots are scattered with no clear upward or downward pattern. So there is no correlation between the variables. For example, a person's shoe size does not predict their intelligence test score. Okay, now let's look at the correlation coefficient. This is a measure of the strength and direction of the relationship between variables on a scatter plot. The AP Psychology exam typically uses the Pearson correlation coefficient, represented by a lowercase r. The Pearson correlation coefficient ranges from -1 to +1. A value close to +1 means a strong positive relationship. A value close to -1 means a strong negative relationship, and a value near 0 means little or no relationship. For example, imagine a scatter plot showing hours of sleep and people's ability to maintain attention. If the dots trend upward and the correlation coefficient is positive 0.65, you would describe this as a moderate positive relationship, meaning students who sleep more tend to have higher attention scores. Now let's look at Cohen's d. Cohen's d is another way of measuring effect sizes, similar to the correlation coefficient. But while the correlation coefficient is used for non-experimental correlational studies to indicate the strength of the relationship between or among variables, Cohen's d is more often used for experimental studies that measure the size of the difference between two groups. Cohen's d is represented by a lowercase d. In the exam, you'll see effect sizes that follow the following structure. Small effect size is usually 0.2 or below, which means the relationship or difference is weak. A medium effect size is usually between 0.3 and 0.7, which means the effect is noticeable but moderate. A large effect size is usually 0.8 or greater, which means the relationship or difference is strong and meaningful. Let's look at an example. Imagine a researcher tells one group they can only sleep for 5 hours the night before the exam, and another group can sleep for 8. In this experimental study, Cohen's d shows us whether extra sleep made a small or large difference in test scores for the group that got the extra 3 hours of sleep. In this study, the effect size is 0.9, meaning the difference between the two groups is strong. In other words, the group that slept for 8 hours scored noticeably higher on the exam than the group that slept for 5 hours, showing that the extra sleep had a meaningful impact on performance. The key idea to remember is this: effect size, in the form of both correlational coefficient and Cohen's d, tells you how much something matters, not just whether it exists. Now let's look at statistical significance. You might read in an article on the exam that the results were, quote, statistically significant. This means that the results were so strong that they were highly unlikely to have just happened by chance. Researchers usually consider a result statistically significant when the probability that it occurred by chance is less than 5%. If you see the p equals less than 0.05 statistic within an article, this is indicating that the results were statistically significant and not occurring by chance. However, while statistical significance tells you the result is unlikely due to chance, it does not tell you how big the effect is. That's why you also need to take into account effect sizes in a study, which will be represented by correlation coefficient, or Cohen's d. Alright, that brings us to the end of the free YouTube version of this lesson. This lesson continues within Mr. Carter's AP Psychology Self-Study and Review System, where we work through interpreting effect sizes and statistical significance in exam-style questions. If you want to continue the lesson or grab the structured study guide, the link is in the description. Okay, that brings us to the end of science practice number 3. Let's move on to science practice number 4, titled Argumentation. The skills in science practice number 4 are specifically tested on the EBQ, where you'll be presented with 3 studies and you'll need to be able to make a claim based upon the study's findings and support the claim with reasoning and evidence. So, for this section, we'll look at what you need to know about claims and then reasoning and evidence. So let's start with claims. A claim is a statement of what you believe is occurring in a scientific study or group of studies. As you'll see later in this lesson, you'll need to be able to back up your claim with evidence. Let's see how this applies to the EBQ. Part A of the EBQ question asks you to propose a specific and defensible claim based in psychological science that responds to the question. For this part, your job is to read across the 3 studies you'll be provided in the EBQ question and identify the main pattern in the results. For example, these 3 studies, which are from the first practice EBQ in my EBQ Mastery Playbook, all find that people with an internal locus of control are more likely to take action when they face challenges. As a quick reminder, an internal locus of control is the belief that the outcomes in your life are mainly the result of your own actions, decisions, and efforts. By contrast, an external locus of control is the belief that the outcomes in your life are mainly determined by outside forces such as luck, fate, or other people. Essentially, these studies help support the idea that people with an internal locus of control are more likely to be fast action takers than people with an external locus of control, because they fundamentally believe that their actions can have a positive impact on outcomes. So, with that said, let's see if we can make a defensible claim about locus of control based upon the study results. An appropriate claim could be, based upon evidence within the 3 sources, a specific and defensible claim can be made that people who believe their actions are effective are more likely to take action and persist when faced with difficult situations than people who believe outcomes are controlled by external factors. In my EBQ Mastery Playbook, I recommend students write their claim for Part A using this template. Based upon evidence within the 3 sources, a specific and defensible claim can be made that, and then make your claim. After proposing a defensible claim, you will be asked to use reasoning and evidence to support your claim. Evidence refers to the findings within the studies. This can include data from tables, graphs, and figures, and information presented in descriptions. It's always helpful to try to present specific facts and data from the studies. For example, this study presents a table showing that 72% of people with a belief that their personal actions influence outcomes took action in a study within 5 minutes, while only 39% of the group who believe that outcomes are controlled by external factors took action within the same time range. To use this as evidence in the EBQ, a student might write, according to Source 1, people with a belief that personal actions influence outcomes are more likely to take fast action than people who believe outcomes are controlled by external factors. In the study, 72% of the group who believed that personal actions influence outcomes took action within 5 minutes, as opposed to only 39% in the group that believed outcomes were controlled by external factors. This example supports the claim made earlier that people who believe their actions are effective are more likely to take action and persist when faced with difficult situations than people who believe outcomes are controlled by external factors. It also presents specific data from the study to help strengthen the evidence and claim. Here is the sentence structure I recommend in the EBQ Mastery Playbook. It reads, according to Source 1, 2, or 3, then insert a statement of evidence. This supports the claim that, and then link your evidence to your claim. Okay, that's it for the free YouTube overview of this final lesson. For more on writing EBQs, you can complete the EBQ Masterclass and practice questions within Mr. Carter's AP Psychology Self-Study and Review System. As this concludes the Unit 0 overview, you should also have completed the study guide now. If you haven't worked through it yet or want to grab the answer key, it's all linked in the description. Thanks for watching and good luck in the exam.